Hey Calculus, welcome back. Our objective today is going to be to apply a chain rule but with a double composition. So I'm going to force a pause on your screen. You know what to do from here. Alright, I'm going to force another pause on your screen. Will you please copy example 1 and then we're going to work these together. Alright, we're back. So this is really just review from the last lesson, but chain rule is very, very important, so I want to make sure we feel good about these before we move on to a double composition. So here for y prime, we're just going to find the derivative for each of these. The outer is secant of x. The 3 comes with us, so what is the derivative of secant of x? It's secant x tan x, okay? But instead of x, I have to hold the baby in where I would normally write x. So the 3 comes with me. Then I'm going to have secant of 4x tan of 4x. So that's the derivative of the outer holding the inner, and then times the derivative of the inner, so times 4. So just cleaning this up a little bit, I've got 12 secant of 4x times tangent of 4x. Okay, for the second one, we have y equals sine squared of x. Now remember, when you're doing these, the very first thing I want you to do is rewrite. Always rewrite your trigs if they have an exponent in them like that. Because we have to be very clear on what the outer and the inner functions are. So in this case, what is your outer? Your outer is that square. So I'm going to deal with that first. I'll fly and subtract, but I have to hold the inner as is. So you can put your understood exponent of 1 there, or leave it off. And then times the derivative of the inner, and the derivative of sine is cosine of x. Good. Okay, for the next one, what's your outer function? Outer function's e to the x. So if I take the derivative of the outer, holding the inner, well, the derivative of e to the x is itself, so I'm going to have e holding the baby, and again, the baby is the exponent, okay? So now multiply by the derivative of the baby. So 5, and I'm going to go ahead and bring that 5 to the front. We always write our coefficients in the front, okay? So in general, if I have y equals e to the ax, y prime, take the derivative of the outer, so that's just itself, holding the inner in its place, then I need the derivative of a times x, which is just a. Okay, so that's the general rule for y equals e to the ax, which is a function that we see quite a bit in calculus. All right, I'm going to force a pause on your screen. Will you please try these 4 on your own? Then hit continue when you're ready to see the answers. Okay, answers are on the screen. Again, derivative of the outer holding the inner times the derivative of the inner. So pause if you need to make any corrections, and then we will go on from here. All right, so I do want to go over question 101 from the previous assignment. They give us function a of t, which tells us the percentage of the market that has second generation smartphones, I believe, with respect to time, where time t is the number of years after 2010. And part A said, find the limit as t approaches infinity of a of t and interpret your result. So, as time goes to infinity, well, I only see t in one place, and that is in that term, correct? Now, is that exponential growth or decay? That's decay, correct? So just that exponential piece looks kind of like that. So as time goes towards infinity, this piece is going to go towards what? It's going to approach 0, okay? So this box here, that is going to go towards 0, the exponential decay. So I get that the limit approaches 102 minus 90 times 0, also known as 102. So I can interpret this as time progresses, 102% of the population has second gen smartphones. So over 100%, I guess some of the population has more than one. Okay, then part C says find the rate of change. Whoa, what do we need to tie rate of change with? We need to tie it to the word derivative, right? So Derivative, slope of the tangent line, rate of change, those are all synonyms, okay? So rate of change of A with respect to time. So what we will have here, A prime of t, right? So what's the derivative of 102? That's 0, that goes away, right? That negative 90 coefficient comes with me. Then let's take a look at the exponential piece. So notice I have a function inside another function. The derivative of the outer is itself, holding the inner. I need to multiply by the derivative of the inner, and notice I just left some space here because I knew it was going to come there. All right, so negative times a negative is a positive, and then if we multiply those two coefficients together, we should get 18.9 e to the negative 0.21 t. Okay, so now let's get to our double compositions. In other words, what if there's a grandma, right? So if there's mom and baby, outer and inner, we differentiate mom, hold the baby, times the derivative of the baby, right? So similarly, if there is grandma, if there's three functions, we'll differentiate grandma, hold mom and baby, times, and then we'll be back to regular chain rule. So times derivative of mom, hold baby, and then times finally derivative of baby. So you're just going to work your way in, just like when we typically work compositions. If we plug in a number, we go from the inside out, right? Now we've got to work from the outside in to get the derivative. All right, so I'm going to force pause on your screen. Go ahead and copy what I have. I'll probably have to get rid of this grandma so we have some more room. Okay, so let's see if we can find the derivatives here when we've got three functions. So let's just talk about grandma, mom, and baby. Make sure we know outermost to innermost. So for f, here's grandma, tangent of x. Mom is ln of x, and baby is 5x squared plus 4x. So we're just going to work our way in, holding everything until we get to that derivative. So here's what I mean. Let's try some. So f prime, I'm first going to take the derivative of grandma, tangent. So what's the derivative of tangent? It is secant squared, okay? Now I've got to hold everything else. Hold mom, hold baby. Okay, so don't read too much into the analogy. So that is gone. Now I keep working my way in. Now I'm at mom. Okay, so now take the derivative of ln. What's the derivative of ln? 1 over, right? 1 over x. So 1 over, but instead of x, I have to hold the inside. Okay. We'll keep working our way in. Now I am to the baby piece. So now what's the derivative of 5x squared plus 4x? Well, I would get 10x plus 4, okay? And that's our final answer. Okay. All right, let's take a look at g of x. Again, let's make sure we're really clear on how many functions we have and that we know our way, working our way out to n. So the outermost function is cosine of x. My next function is e to the x. And then my baby is negative 3x, okay? So again, we're just going to work our way in. We're going to go blue, red, purple, okay? So g prime, the derivative of blue of cosine is negative sine, so hold everything else, times, now keep working your way in, derivative of e to the x is itself, again, hold everything else, then times the derivative, the baby is negative 3x, so the derivative of negative 3x is negative 3. Yep, now let's just clean this up a little bit. So I've got a negative times a negative, so that'll be a positive. Let's bring that 3 to the front, and I'm going to go ahead and bring the e forward as well. And then I've got sine of e to the negative 3x. All right, do we know what we need to do first for this last one? I really need to rewrite, okay? So sine of 3x to the 4th minus 11, all of that squared, okay? So the outermost function is the square. Then I've got sine, and then my innermost function is 3x to the 4th minus 11. All right, let's try it. So y prime, I need to deal with the square first, right? So I'm going to fly, hold everything else. Okay, and I really do, when you've got more than one, I recommend just kind of marking them off as you go so you can tell where you are next. All right, then times, my next function as I work my way in is sine, whose derivative is cosine. Hold everything else. Times, and then my last function is 3x to the 4th minus 11, whose derivative is just 12x cubed. And again, let's just bring those, let's make sure the trig terms are at the end. So, final answer, y prime is equal to 2 times 12 is 24. I'm bringing that x cubed with me. Sine of 3x to the 4th minus 11 times cosine of 3x to the 4th minus 11. So that is how we deal with grandma when we have more than one composition. So I only have one grandparent still remaining. This is my dad's mom, my grandma, also known as Glamma. It takes her many, many hours to get ready in the morning. She lives in Sweden, although she's from Iran. So we got to visit, the last time we got to go was 2 years ago. Jonas was a year and a half, but that's 4 generations pictured there. So my grandma, my dad, me, and Jonas. So that's grandma, that's Glamma. So that's all I have for you all today. We will do some more practice with this. You've got a couple more assignments so that you can really get solid on chain rule. All right, I'll see you all next time.